Well, hi everyone. At this practice test here, we will go through I'll just use a pen. Okay. First part here, we are kind of working with the simplifying monomials and those exponent rules. And this is multiplication. And if I were to just kind of take the parentheses out and rearrange it, I would take the 2 times the negative 7, those two coefficients, then the x terms, the x to the negative third times x to the fifth, and then the y terms, y to the third times y to the negative sixth. And 2 times negative 7 is negative 14. And then negative 3 plus 5, you add the exponents there, that's x to the second. And 3 plus negative 6, that's y to the negative third. And then one more step. I'm going to put the negative 14x squared, and to make this a positive exponent, all exponents should be positive, it says, we bring down the y to the third. Y to the negative third on top becomes y to the third on the bottom. Okay, now on this next one, I'm going to write it out. 15 over negative 3, c to the fifth over c squared, d to the third over d to the seventh. And this is regular division, the coefficients. We subtract exponents here. 5 minus 2 is 3. 3 minus 7 is negative 4. And I'm going to do what I did on the previous problem. I got to make that negative exponent a positive exponent. So I got negative 5c to the third over d to the fourth. Now when you get a fraction to a negative exponent, I think one of the best things you can do is flip the fraction, take the reciprocal and change it to a positive exponent. And then the quotient property, it'd be 4 to the third over a to the third. And 4 times 4 times 4 is actually 64. So 64 over a to the third there. This is the power of a product, and negative 2 gets raised to the fifth, x to the third gets raised to the fifth, and y squared gets raised to the fifth. And now it's power to a power. Now negative 2 to the fifth power is negative 32, if you do that. And then x is to the 15th power, y is to the 10th power. And now we're into the polynomials here. We're going to add them. We add the like terms. This is addition, this is subtraction. These are multiplication. So, and addition. So, I'm going to, first of all, I got 6x squared minus 7x plus 8 plus negative 4x squared plus 9x minus 5. Now my 6x squared and negative 4x squared, when added together, make 2x squared. My negative 7x and my positive 9x, negative 7 positive 9 is positive 2x. And then positive 8 and minus 5, 8 and minus 5, that's plus 3. I'm going to do this one the same way, but after the minus, I got to change these signs. So no parentheses here. 4x squared minus 5x plus 6, negative 2x squared, negative 3x, and positive 1. And 4x squared minus 2x squared is 2x squared. Negative 5x negative 3x is negative 8x. Positive 6 and positive 1 is positive 7. This is distributive property. Negative 2a times negative 3a squared, that is positive 6a to the third. A times a squared is a to the third. Negative 2a times negative 11a is positive 22a squared. Negative 2a times 20 is negative 40a. This one, I'm going to FOIL. and you can make a box if you want here, but I'm going to FOIL. First, 2x times 3x is 6x squared. Outside, 2x times 4 is 8x. Inside, negative 1 times 3x is negative 3x. Last, negative 1 times 4 is negative 4. The two middle terms are like terms, which I'm going to combine. 6x squared, 8x minus 3x is plus 5x, and then the minus 4 doesn't have a like term. Now this one, I am going to make a box on this one. Three terms up here, x squared, negative 3x, and 4, and then two terms, x and 3. X times x squared is x cubed. X times negative 3x is negative 3x squared. X times 4 is 4x. X squared times 3 is 3x squared. 3 times negative 3x is negative 9x. 3 times 4 is 12. All right, I have an x cubed. These two are x squared terms, but they cancel out. Negative 9x plus 4x is negative 5x, and then the plus 12. This one, I am going to use the distributive property here, the distributive property here, and then add like terms. 5c times 2c squared is 10c to the third. 5c times negative 3c is negative 15c squared. 5c times 4 is 20c. I'm done distributing here, and now I'm going to distribute here. 2c times 7c is 14c squared. 2c times negative 8 is negative 16c. So I have 10c to the third. I've got negative 15c squared and positive 14c squared. That's negative 1c squared. I can put the 1, or I don't have to. And then I have 20c and negative 16c. That is positive 4c. All right, page 1 done. Now, this one, and I've got more here than what you'll have on the test, but I'm just trying to cover all our bases. Okay, we are graphing a linear inequality. So I'm going to graph the related function with either a solid or dotted line. Now, I'm actually going to have these on the test. You still need to know how to fill in the blanks. We're going to test a point that is inside the parabola to see if the inequality is true or false. If the statement is true, then shade inside the parabola. If false, then shade outside the parabola. All right, I need to graph y equals x squared plus 5x minus 6 with a dotted line, because the dotted, it's just greater than. If it was greater than or equal to, I'd use a solid line. Now, remember negative b over 2a, give me the equation for the axis of symmetry. So that's negative 5 over 2 times 1, which is negative 2.5. I'm going to make my little table. This is to, so I'll go negative 2.5, and I'm going to go negative 2, negative 1, and I'm going to go negative 3 here, negative 4. So at negative 2.5 squared plus 5 times negative 2.5 minus 6. Let's see how this graphs. Get my beloved calculator out here. All right. Negative 2.5 squared plus 5 times negative 2.5 minus 6. Negative 12.25. Dang, that goes a little bit below my graph. That's all right. I might extend this a little bit. Negative 2. Negative 2 squared plus 5 times negative 2 minus 6. That's negative 12. And I have a feeling with the vertex and that both being a half unit off of the vertex, that's negative 12. Negative 1. So negative 1 squared plus 5 times negative 1 minus 6. This is 1. Minus 5 is negative 4. Minus 6 is negative 10. So this is negative 10. I'm going to go a little bit further with this. Negative 5 and 0 would be the same. And I do know 0 is going to be negative 6. And this will be negative 6. Let me go one more. I'm going to put 1 in here. And I have 1 squared plus 5 times 1 minus 6. That's 0. Okay, that's a good one to see. So I'm just making a table here. Okay, vertex negative 2.5 right there, negative 12.25. Here is negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 11. Negative 12. Negative 12.25 I'll put right here. Negative 2, negative 12. Put right here. Negative 3, negative 12 is right here. Negative 4, negative 10. Negative 1, negative 10. 0, negative 6. 9, 8, 7, 6. And negative 5, negative 6. And then I do know I make it to 0 at 1, and I'll make it to 0 here too. I'm using a dotted line. I'm going to change colors because this is fancy. I'm going to make a dotted line. I like to do this part to make the curve look right. So here's my dotted line for my parabola. Now pick a point inside the parabola. I'm going to take, it doesn't matter, it really doesn't matter, but this point is inside the parabola. It is 1, 2, negative 3, 0. And I'm going to see if it's true or false. So I have y is greater than x squared plus 5x minus 6. Y is 0 with my test point. Is that greater than negative 3 squared plus 5 times negative 3 minus 6? So that makes 0 greater than 9 minus 15, negative 6. Okay, 0 is greater than negative 12. I already knew that negative 3 would give me negative 12. I wasn't thinking about it. 0 is greater than negative 12. That is true. So I think that we will shade this inside the parabola. All right, the next thing is, this is number 11. It's basically the same thing. I changed only this part here. So I'm going to actually make that graph again. Negative 2.5, negative 11, negative 12.25. Remember, we went here and here. Negative 1, negative 10, and negative 4, negative 10. 9, 8, 7, 6, 0, negative 6, negative 6 here, and then we hit zeros here and here. All right, so let's draw our dotted line here. Now, if I put that test point again, I'm just showing a different inequality and how to handle it. If I use the test point again, but this time y is less than or equal to x squared plus 5x minus 6. But this time, I would get, okay, test point is negative 3, 0. Now, I've already gone through a test point of negative 3, 0 here. So I'll have 0 this time is less than or equal to negative 12. 0 is less than negative 12. That is false. And if it's false, I will shade outside the parabola. And so that would be this area right here. The points outside are true, the points inside are false. The only thing I did was change that and do everything the same. Test point's negative 3, 0. This is kind of what I've done on all these. We're going to solve this by graphing. I've got it says graph the related function, make sure the zeros, the x-intercepts, are plotted. It's important to make sure those are plotted. Look to see which part of the graph is above the blank for blank and write the solution inequality. Look to see which part is below the blank for, okay. All right, so what we're going to do here is we're going to graph the related function. We're going to graph y equals, and using equals, x squared plus 3x minus 4. And I'm going to use the negative b over 2a again. And that's negative 3 over 2 times 1, which is negative 1.5. Negative 3 divided by 2 is negative 1.5. And we got negative 1.5 here. Negative 2, negative 1, 0, 1. Negative 3 would go 0, negative 4 would go here. Okay, negative 1.5 squared plus 3 times negative 1.5 minus 4. Plug it in. Negative 1.5 squared plus 3 times negative 1.5 minus 4. It's negative 6.25. Now, if I put negative 1 in, negative 1 squared plus 3 times negative 1 minus 4. I could have done this in my head. That's negative 6. This one's going to give me negative 6. 0 is going to give me negative 4. Negative 3 would give me negative 4 because of the symmetry. I'm going to do this one real quick. 1 squared plus 3 times 1 minus 4. That's 1 and 3 is 4. 4 minus 4 is 0. Alright, and this is 0. So make sure the zeros are plotted. So these zeros will be plotted. We kind of lucked out there in the table. Sometimes they're not always in the table. I went far enough that it was. Let's plot this then. Negative 1.5 and negative 1, 2, 3, 4, 5, 6.25 right there. Negative 1, 6, negative 2, 6, 0, negative 1, 2, 3, 4, and negative 3, negative 4, and then 1, 0, and negative 4, 0. And I think we're in business here. So we're graphing this. Let's see. Okay, just trying to get a decent idea. I'm going to graph this function. I'll go all the way to the top here. All right. Now, look to see which part of the graph is above the x-axis for greater than or equal to, and write the solution inequality. And this is a greater than. Look for the axis below, look to see which part of the graph is below the x-axis for less than or equal to. All right, this is greater than. I'm looking at this part right here. This is above, so it's this part of the x, and this is above, and this part of the x. I'm going to change colors there. Change that to red. So my solutions would be, final answer, x is less than, these would be open circles here, negative 1, 2, 3, 4. So we got to know that 0. X is less than negative 4, or x is greater than 1. Those are the solutions for that when they look at the part of the graph that's above there. All right. The graph of this is the same, so I'm going to regraph this. This time it's x squared plus 3x minus 4 is greater than 0. Oh, okay. Let's change this. I forgot to rewrite this. Let's make this less than or equal to 0. And I'll try to remember to do that on the practice test tomorrow. Make sure we make that note tomorrow, because otherwise it's the exact same thing. I want to just change it up enough. And negative 1.5, negative 1, 2, 3, 4, 5, 6.25. Remember these. Remember that, and I remember this, and this. And we want something like this. Now this time, this is less than or equal to. Okay. We're looking at the part of the graph that is below the x-axis for less than or equal to. So from here to here, and I'm going to color those in because it's or equal to, and write the solution this way. X is less than or equal to 1 and greater than or equal to negative 4. Okay, when it's in between like this, we're looking at this part here. Here we're looking at the part above. It's always above from here on out, but here, from here to here, it's below the graph. All right. I did remember to switch it on 13. Again, it's kind of the same problem. we are finding the zeros for x squared plus 7x minus 15. I gotta know when it is equal to 0. This is not going to factor. You can't multiply to negative 15 and add to 3. Add to 7, I'm sorry. Multiply to negative 15, add to 7. That's just not going to work, I don't think. I don't think there's anything that's going to do that for us. So we're going to use the quadratic formula. Remember, x equals negative b plus or minus the square root of b squared minus 4ac. I'll love that over 2a. And a is 1, b is 7, and c is negative 15. Okay. Negative b. So negative 7 plus or minus the square root of 7 squared minus 4 times 1 times negative 15 over 2 times 1. We're looking at negative 7 plus or minus the square root of, and I'm getting, this is 49 plus 60, which is 109 over 2. Okay, we've got to get the square root of 109 here, and we're going to round on these guys, so I'm going to go 2 decimal places. Square root 109, 10.44. So I'm not going exact now. We're not going to simplify our radicals. We're going to use the decimals in this unit. So I've got to get negative 7 plus 10.44 and then divide that by 2. And then negative 7 minus 10.44 and divide that by 2. I need those 2 values because I'm finding the zeros first. So this first part is just finding the zeros. Negative 7 plus 10.44. Whoa, got your 7 there. Let's just start again. Negative 7 plus 10.44 is 3.44 divided by 2. I'm going to divide that by 2, and I get 1.72. There's one of my zeros, 1.72. This is negative 17.44. When I add those 2 together, divide that by 2. Negative 8.72. All right, so I said find the zeros and put those on a number line. I'm going to put negative 8.72 here. I'm going to put positive 1.72 here. I'm going to put closed circles on these 2. I'm going to test, and you can test anything. I'm going to test negative 10. That is negative 10 squared plus 7 times negative 10 minus 15. And then that's 100 minus 70. And then I'm seeing if this is greater than or equal to 0, by the way. That's 100 minus 70 minus 15. That's 100. Well, 100 minus 70 is 30 minus 15. Is 15 greater than or equal to 0? This is true. It's true here. I'm going to use 0 here. Using negative 10. I'm going to use 0. And the 0 squared plus 7 times 0 minus 15 greater than or equal to 0. This is 0, this is 0. This is negative 15 is greater than or equal to 0. That is false. Okay, so I'm true here. I'm going to shade this side. I'm false from here to here. I use 0. Anything that I test in here is going to be false. Now I'm going to test something bigger. I'm going to test 2. A number that's bigger than 1.72. Right here, 2. I didn't finish my thought there, did I? Now, 0 squared, not 0, 2 squared plus 7 times 2 minus 15. Is that greater than or equal to 0? This is 4 plus 14 minus 15 is greater than or equal to 0. 18 minus 15 is 3, and 3 is greater than or equal to 0, so that's true here. So I'm going to shade this side. Alright, so I kind of got it graphed. My final solution, I'll just write up here, x is less than or equal to negative 8.72, or, when they go away from each other, I'll write or in between them, x is greater than or equal to 1.72. Alright, that's the... Now, I did basically the same problem with a different inequality. The zeros are still 1.72 and negative 8.72. And I've got negative 8.72 here, positive 1.72 here. I'm going to put open circles because it's just less than. And I would still test. If I test negative 10, now look at my work right there. If I test negative 10, I get 15, but this time I have 15 is less than 0. If I'm testing negative 10, that is false, because 15 is not less than 0. If I test 0 here, I will have 0, when I plug that in, that's negative 15. Only this time it's less than 0 is what we're testing. Is negative 15 less than 0? That is true. So from negative 8.72 to positive 1.72, that is true. And then if I test 2 again, 2 gave me 3. Is 3 less than 0? No, it's not. That's false. So my solution here to this one, that line, would be x less than 1.72 and greater than negative 8.72. Okay, that is that, guys. Take care. God bless.